Okay. So, hello students. Uh, Today I'll introduce a special topic. This is probably the hardest topic in mathematics. It is actually calculus. Okay. So, it is the hardest topic actually, but you guys actually are very smart, I think. So you can manage it. And I'm very full, right? So today's topic is named calculus for full, right? Calculus for full. Okay. So let's see what a fool can do, what a fool can take. Right. So first of all, I'll introduce two symbols, right? One is a D, right? It is a D. Just spelling is D, D. It means little bit of, little bit of. Okay. And a large S, right? Secondly, is a large S. It is actually. If you have a S and stretched it out two ends, you get this thing, right? It is a large S. A large S, and it means sum of. Sum of. Okay. Okay. It is the two symbols. I will just introduce to you. And okay, so let's think what is this actually. Okay, so if you have a straight line with the length x, right? With the length x, and okay, so what is actually dx, right? Dx means d means little bit of. So dx means just it's your actually literature. So dx means a little bit of x, right? A little bit of x. Okay. So if you have a large straight line of length x, and if you cut it a very small piece, so one of this piece you can call is dx, right? Because it is a little bit of x. The very large thing x, the small piece is the dx. Okay, little bit of x. So it is a dx, it is a dx, it is a dx, right? And what is this symbol means? It is a sum of little bit of x. I mean, if you add, sum of means just addition. If you add this dx plus dx plus dx plus dx plus dx, what do you get? It's the full length of this straight line. That means the x. Okay. So it is sum of little bit of x means x. Very simple. Okay. Do you know actually what is if you have a clock, right? Clock, also known as clock. The clock is a 12, 6, 3, 9, and there are three hands actually. It is an hour hand, minute hand, second hand. Okay. So where is the minute comes from? Do you know it? Where the minute comes from? Okay. Actually, if you have a span of time 1 hour, right? So 1 hour, and if you cut it in 60 equal parts, right? 60 equal parts. In one of these parts is called 1 minute, right? Okay. Now just thing. Just spelling of minute actually. Minute. M-I-N-U-T. This is actually minute, na? It's a minute, right? Look at the spelling. Minute. So actually, it is actually the minute fraction of an hour. Okay, so minute fraction. I mean, if you break the span of time of 1 hour in 60 equal parts, so 1 part of 60 is a 1 minute. It's a 1 minute fraction of an hour. Okay, and what is the second actually? If we have span of time of 1 minute and if you cut it in 60 equal small parts, one part of this is called 1 second, right? 1 second. Actually, second means the second minute fraction of an hour. Right? 1 minute means the first minute fraction of an hour. The second means second minute fraction of an hour. Right? So it is the second minute fraction. It is the minute section actually. Minute is the span of time of 1 minute, and if you cut it very smallest part, you will get second, 1 second. Okay. That's the second means the second minute fraction of an hour. So just simple thing. These are actually 60 minutes here for 1 hour span of time. So actually 1 hour means 60 minutes and 1 minute means 60 seconds, right? So what is 1 hour actually? It is 60 into 60. That means 3600 seconds. Okay. Just compare with 1 hour and 1 second. 1 second means actually 1 over 3600 hour. Actually, if we have a 1 hour span of time and breaks it 3600 parts, equal parts, the 1 part is called 1 second. Just imagine how the smallest is in comparison with 1 hour. 1 second is very small, right? So you can ignore it, just 1 second. In comparison with 1 hour, you just ignore it 1 second. If it is, I'll call this t, so what is 1 minute actually? The minute fraction of time. I mean the smallest, I mean the actually little bit of time, right? Little bit of time. So little bit of t actually. So this 1 part is called dt. Okay. So 1 minute means a dt. If it is a t, and then what is 1 second actually? If it is a dt, 1 minute means dt. The second fractions, I mean d dt, right? That is d squared t. Okay, so in comparison with t, you can cancel it out, right? Because it is a very small fraction in comparison to an r. So you can cancel out, you go to 0, right? So let's do another example here. Just think, today your father tells you that 1% of my today's income I'll give it to you, right? And you tell your brother that whatever I'll get from my father, so 1% of this amount I'll give it to you, right? So with your father, you and your brother, right? Let's assume your father's today's income is 1000 rupees. Okay. So now, what amount will you get? The 1% of it. And very simple, 10 rupees. And what amount your brother will get? It's very simple. 1% of 10 rupees, that is 0.1 rupees. I mean 10 paise actually. Okay. Okay. So actually, comparatively, 1000 rupees, the 10 paise. It is just negligible quantity. You can ignore it. Actually, your brother tells you, ये amount to रख ले भाई, ये मेरे को नहीं चाहिए actually, because in present time it is a very negligible quantity. कुछ भी नहीं है यहाँ पे. 10 paise means just zero, nothing. Okay. So if it is x. So what is this? The small fraction of this thing. So you can write it dx, right? Because dx is little bit of, and x means here, so it's a little bit of x and little bit of that money. And what is this thing? If it is dx, it is another small fraction of this thing. So it is a d of dx, right? So it is a d squared x. So in comparison with x, the d squared x is very small. You can cancel. Okay? So it is 0. Okay. Now just imagine you have a second brother, very small actually. His child is a brother 1 and a brother 2. And if the brother 1 tells the brother 2 that whatever I will get, just 1% of this money I will give it to you. So let's imagine the 0.1, the 1% of it, what is this thing actually? Is 0.001 actually. It is a rupees actually. So it is another negligible thing, right? Because it is a very small quantity, right? So actually, if it is a d squared x, then another small fraction of this thing, the d of d squared x, so d cubed x. So you can cancel out, right? It is 0, right? In comparison with x, 1000 rupees and it is a 10 paise, and it is at 0.001 rupees. You can cancel out. Okay? Okay. Okay. So there is some geometrical example. Right? Okay. So there is a rectangle of length x and the breadth y. Right? It is x and it is a y. Okay. So, if you increase this length in a very small amount and a little bit of x, right? Very small amount. This is a dx. Okay. It is actually a dx. And if you increase the breadth of this rectangle in a very small amount, so it is a y and it is dy. Okay. So now the area of the new rectangle begins. You draw this thing here. Okay. So I will black it this thing actually. Okay. So it is a small patch of this area and it is another small patch of this area. So what is this area actually? It is x and it is a dy. So here it is x into dy, and what is this small area actually? It is a y, it is a dx. So it is y into dx. But what is this thing actually? It is a very small thing, probably invisible. It is a visible, right? It is a x dy which is probably visible. you can calculate what is this thing, and obviously it is also visible y dx actually, right? But what is this thing actually? It is a y dx, and it is a x dy, and then it is actually it is a dy and it is dx, right? So this black patch, you get dy into dx. It is a very small area. You can ignore it, right? So it is invisible, right? So actually dy into dx means the very small quantity into very small quantity, right? Let's dy means 0.001 and dx means 0.0001. What do you get? 0.000001, right? And it is a very small, right? So you can ignore it. Okay. Actually, product of the small quantities, the very small quantities, you can ignore it. And then we learned previously d2x or d3x and d3 or d4x, right? So it is 0 actually in comparison with x. So it is 0, right? Okay. Okay. Now what is dy actually? Dy means simple, d means little bit of y. Okay, and d means little bit of, so dy means little bit of y, dx means little bit of x, dt means little bit of t, dm means little bit of m, something like that. Okay. Now our subtopic is right now actually dependency, right? Dependency. Dependency is a very simple thing. You depends on your father, you depends on your mom. Obviously, reverse is true. Your mom depends on you, your father obviously depends on you. So mathematically, some quantities depends on some another quantities, right? Okay. So let's evaluate these things. Let's explain this thing. Okay. So if there a rectangle, if it is the length of this rectangle is x, and if the breadth of this rectangle is y, and I restricted this, you can change length or breadth, anything, but the area of this rectangle should be constant, and the area of this rectangle should be fixed. Okay. So if you change the length by an amount, okay. So let's value. Let's give the values of this thing. Let's it is. I'll put a coordinates here. Let's start with this. Here is 0. And it is somehow 2, and it is somehow 1. So actually the previous case, the length of this rectangle is 2 units and the breadth of this rectangle is 1 unit. Now if you increase the length to the 4 units, okay, so by a restriction, the constant area, so you should put your breadth actually half, right? Because half into 4, okay, so previously the area will 1 into 2, that means 2, and now the 4 into half, it is 2, right? So by a restriction, if you increase the length of this rectangle, the breadth of this rectangle decreases some amount, right? So you can draw relations between length and breadth. If the length is called x and the breadth is called y, you just draw y proportional to 1 by x. So it's inversely proportional to x because if the length is increased, the breadth should be decreased by a restriction, right? It is a dependency, right? X depends on y or y depends on x, right? Okay. Now for another example, if you have a triangle, right? If you have a triangle and the base, I call the base is x and the height is y, and I put here a restriction, you can change the length or you can change the base, the length of base, the length of height, but the slope of this triangle should remain constant, right? There are restrictions. The slope of this triangle should remain constant. Or you can change the length and base and height. Okay. Okay. So if you change, if you increase the base, small, this time almost something. So by a restriction, you should increase the rate, height also, right? It is your initial height and obviously the final height. So if I restrict here, the slope should be unchanged and slope should be constant. So if you increase the length of the base, you should increase the length of the wire and length of the height. Okay. Okay. So here you can put a relationship, you can draw a relationship between y and x by a restriction that y proportional to x, right? Because all of them are slope actually. Slope means this height by base. So height by base actually is slope, and here some height by base actually a slope. So if I restrict slope is constant, but if you increase the base, you should increase the height. So actually, if x is increased by some amount, then y should be increased, right? This is a dependency actually. Okay, this is a dependency. Okay. Now, if something depends on something, mathematically I will express it another symbol, right? Is another symbol here. It is a function of. The symbol called. The symbol means a function of. Function of, or depends on. Depends on or the relation with. Okay. The symbol you can call the function of or depends on or relation with. Okay. Okay. So if I write here, what do you call this thing? Y is a function of x, or y is a relation with x, or y is a relation, or y depends on x. Okay. Actually, the function of x means anything for x actually. It can be x, it can be x squared, it can be x cubed, it can be 1 by x, it can be 2 by x squared, it can be anything e power x, whatever. Okay. Sin x, cos x, anything with x is called a function of x. Right. Okay. Now, our task is to calculate dy by dx. It is dy by dx. Okay. Okay. Now, so let's proceed. The very simple relationship. Let's y equals to x, right? Y equals to x, and I want to calculate from here dy by dx. Okay. Okay. So if x increased by a very little bit of, I mean, if x increased by around dx, so obviously y should increase, or y, I actually have relations here. If x is increased, y should be increased. Oh, actually, if x is changed, then y is changed. Yeah. So y will always change. Oh. So if x, I will increase the x by around dx, so the new x becomes x plus dx, right? And from this change, y should be changed, and the new y becomes y plus dy. Okay, this is the new. These are old and it is new. So from this old thing, or from this old equation, what is the new equation? Just put it here. Instead of y, so y plus dy, and instead of x, just put x plus dx here. X plus dx. Okay? It's a new relationship. Okay. So what is x actually? From this old equation, x means y. Just write it instead of x, it is a y. And all of you know, we cancel out. So dy equals to dx. So what is dy by dx? It is actually 1, right? Okay. So if you have y equals to x, then dy by dx will 1. Okay. Now, then for another example, if y equals to x squared, then what will happen for dy over dx? Okay. So I will proceed the same thing. If x is changed from x to dx, the new x becomes x plus dx, and the new y obviously becomes y plus dy, because it is a relationship, right? If x is changed, then y should be changed. That is a relationship. If the new x is x plus dx, then the new y becomes x plus dy. So it is a new condition, right? Oh, and these are old. Okay. So from this old equation, if you plug in here, instead of x, it's the x plus dx, and instead of y, it is x plus dy, you will get a new relationship. Y plus dy equals to is squared. Just plug in here. Instead of x, is the x plus dx, right? So x plus dx squared, right? Oh. And all of you know is the a plus b whole square. So what is the formula? So x squared plus 2x dx plus dx squared, right? This is the y plus dy. And from our previous demonstrations or previous calculations, is a very small quantity, right? It's actually dx squared. So you can cancel out because it's a very small quantity in comparison with x. Okay, so it is a x squared plus 2x dx. It is a y plus dy. And from our old equation, you can write instead of x squared, it is a y, right? X squared means y. So x squared means y. So you can cancel out. Now it is actually dy equals 2x dx, right? And what is dy over dx? All of you know dy over dx, it is a 2x, right? So very simple. 2x. Okay. So if it is y equals 2x squared, you will get dy over dx is a 2x. Okay. Okay. And now let's put another example here. If y equals to x cube, then what will happen with dy over dx? Okay. The same thing and proceed here. If nu x will become x plus dx, I mean if the change of x is dx, very small amount, then nu x becomes here x plus dx, and from this change of x, the nu y becomes y plus dy. If x is changed, then y should be changed. Okay, so it is a new thing, new x and y. It's a old thing. So the similar thing, just put it here instead of y, so y plus dy, and instead of x, just plug in it here, just x plus dx. Okay. So the new equation becomes y plus dy equals x instead of x, just plug in here x plus dx cube. And all of you know actually it is a plus b whole cube. So what is this thing actually? It is a x cube plus 3 squared dx plus 3x dx squared plus dx cube. And obviously it is a very small thing, x squared in comparison with x, it is more smallest things. Okay. So these two you can cancel out. Now you left out the equation y plus dy equals to x cube plus 3x squared dx, right? What is x cube here? So our old relationship, x cube means y. Just put it here, y. And y cancel out. So right here, you left out an equation, dy equals to 3x squared dx, right? And what is dy over dx? It's a very simple thing. dy over dx equals to 3x squared. Okay. So if y equals to x cube, then dy over dx becomes 3x squared. Okay. dy over dx equals to 3x squared. So, if y equals to x to the power 10, what will be dy over dx? Just a similarity here. It is a 2. It is a 2 and 2 goes to the coefficient here. And this x means x over x to the power 1, that means one step lesser from 2 is a 1. And here is a 3, power of x is a 3, 3 goes to the coefficient here, and the 2, that means one step lesser from the 3. So by intuition, if there y equals to x to the power, x to the power 10, we can calculate dy over dx. Here, a 10 goes to the coefficient here, 10, and then x, and the power just one step lesser from 10. That means 9. Okay, actually it is. And if y equals to x to the power 100, so obviously dy over dx becomes 100 goes to the coefficient of x, 100, and x, then the power of x will become to one step measured from 100, that is 99. Okay. So if y equals to x to the power n, in general, what is dy dx? The n goes to the coefficient of x, n is the x, and then the power of x will to one step lesser from n, that is n minus 1. Yeah, it is a general formula actually. Number one formula, right? If y equals to x to the power n, so dy dx goes to n x to the power n minus 1. Right? Okay. Okay.